Hello and welcome to this last video of chapter 1. I want to say two things actually. So first, Bolzano is a city in the north of Italy, and Bernard Bolzano was an Italian priest and mathematician, but his native language was German, so he wrote in German. Okay, so in Italian it's pronounced Bolzano, and the other one was Weierstrass, German mathematician. Okay. Now I'm going to implement the simple algorithm that I explained in the last video about approximating radical 2, right? Or any radical if you like. So if you start with x equal 2, x equal 2, actually I'm using Python now, and with Jupyter Notebook as a text editor because it's interactive. Now, unfortunately, I don't have time to teach you Python, but there are many great resources online, so you can learn it for free. You can also, if you pay some money, you get certificates. For example, you can learn it on Coursera, on edX, and it would be a big plus for you, a big advantage when you apply to jobs and other universities. Okay, so it's, in my opinion, every mathematician should know Python and should also know LaTeX, which is a language for typesetting math that I use in the lectures. So I really encourage you to learn this beautiful language. It's very intuitive, and most universities these days teach it at the first year. Even at schools, actually, it's taught. So if you have time, please learn. It's a big plus for you, actually. Okay, so but now I'm going to do something very simple. So I'm going to do a loop, start with x equal 2, and do an iteration because so for n in range of, let us say, 4, 2 points. Now you don't need to use more than one variable here, so you can just update the variable x. So instead of using another variable, you can use the same one. It's not so. I just implement the induction, the recurrence relation. So xn plus 1 equal 1/2 x n plus 1 over x. Okay, so it's very, very, very simple. And if you want to see what's happening at each step, you just print x. You can print 2 if you like, and just shift enter. So we see that we start with 2, then 1.5, 1.4, 1.66, etc. And this final result, the x4, should be correct actually to 9 decimal places, but you will see that actually it's accurate to 11 decimal places. But let me do just a remark here. If you don't know Python, there are no brackets, curly brackets in Python, but instead there are indentation. Okay. So you note that the body of the loop is to the right, shifted to the right. So if you don't respect the loop, this indentation actually get errors. Okay, so don't worry if you get this error, because this is the problem of indentation. Okay, which makes things more clear actually. Okay, so in no time I have a very good approximation, an excellent approximation of radical 2. Let us now compare it with the built-in function. So, for example, it's in the library math, so we import math, and let us print math.square root of 2. And you see actually a very good, they agree up to 7 here, so these are 11. So okay, if you want a bigger precision, actually, let us go to 5, and now we have an agreement to 16 decimal values. Okay, and of course now I want also to illustrate the fact that you need not start from 2. You can start from anything positive actually. So we can start from 1, and actually you see that if you start from 1, the next iteration will be bigger than radical 2. So actually the sequence is decreasing not from 0 but from 1. Okay, but I chose just to simplify things and to do estimates. You can start with something else. You can play actually. You can start from 0.5. What happens? If you start from 0.5, you have actually it's a little bit slower because if you start from 0.5, the next step you get 2.25 and then only 1.5 and then we start decreasing. So actually it's less accurate. You need more iterations because the error estimates that I did were for just x0 equal 2. But you can do something similar from any initial guess, provided actually it should be positive, because if you start from something negative, everything would be negative and you will not converge to radical, you would converge to minus radical 2. Okay? For example, just to test, if we start from minus 0.5, yeah, we'll be converging to minus radical 2. Okay? Because now the sequence is negative and it's increasing. Okay, actually decreasing then increasing. So it would be an approximation of minus radical 2 from below. Okay, anyway, so that's it for this video. I hope that you learned something useful, and see you next time. We'll start a new chapter about sequences. So this could be considered as an introduction to sequences. And thank you for your attention, and see you next time.